Chronicle of the first interstellar voyage to another Earth. In the year 2025, Earth was at a crossroads. The damage caused by climate change, overpopulation, and dwindling resources had pushed humanity to the brink. Yet, in the face of adversity, a spark of hope ignited. The dream of traveling among the stars, once confined to the realm of science fiction, began to take shape as a tangible solution to ensure the survival of the human race. A coalition of the world's leading space agencies, private aerospace companies, and governments formed the Interstellar Colonization Initiative, the ICI, with a common goal: to embark on humanity's first journey to the stars. The Great Anomaly of 2047 was the point of no return. That year, Greenland's ice collapsed in a single summer, releasing 600 billion tons, or 661 billion US tons, of fresh water into the sea. New York, Mumbai, and Shanghai disappeared under 3 meters or 10 feet of ocean. NASA satellites recorded a global sea level rise of 2.3 centimeters or 0.9 inches in a month. It was then that the world understood there was no more time for debate. The numbers were clear. Phosphorus reserves, essential for agriculture, would be depleted by 2060. 40% of arable land had become sterile due to salinization. Water wars in the Sahel were killing more people than World War III. But the final blow came in 2053, when the Venter report revealed that oceanic plankton, responsible for 50% of Earth's oxygen production, had decreased by 70%. In 50 years, we'll have to take turns breathing, headlined the New York Times, and satire quickly turned into prophecy. Amidst all that chaos, there was an astronomer who had been working for years in a bunker, remotely analyzing data from the 39-meter or 128-foot extremely large telescope located in the Chilean Atacama Desert. No one knew yet, but in 2051, Dr. Elena Soto had discovered a planet in the Tau Ceti planetary system, a yellow star just slightly smaller than the Sun, 12 light-years away from us. It could have been just another planet found in that system, but this time, the extraordinary observational capacity of the 39-meter telescope left no doubt. This was a planet whose habitat was absolutely compatible with human life. Not another, almost Earth-like so many others, but a planet whose physical and chemical characteristics could be judged indistinguishable from our own. A diameter of 13,330 kilometers or 8,286 miles. A mass of 0.95 Earth masses. Density and surface gravity just slightly lower. It was at a distance of 122 million kilometers or 76 million miles from its star, with an average temperature of 18 degrees Celsius or 64 degrees Fahrenheit in the equatorial zones. Pronounced polar ice caps, an atmosphere with 25% oxygen, 72% nitrogen, and the rest water vapor. And to top it off, shallow oceans and brackish lakes covering 60% of the surface. The dream of any astrobiologist. And this time, it wasn't a matter of debatable data or mere hypotheses. The 39-meter Chilean telescope, with all its light-gathering power and instrumentation, was telling us that this was absolutely real data. The news was kept under wraps by the media until 2054, when a hacker from the environmental group Last Breath stole the data and leaked it online. The video went viral. Thermal maps of liquid oceans, climate models showing a stable water cycle. "There's another Earth," screamed the headlines. The revelation sparked a wave of excitement and debate within the scientific community. Could humanity really reach another star? The logistical challenges were immense. The journey to Tau Ceti would take about 120 years, far longer than the lifespan of any individual human. Consequently, the concept of a generation ship, a vessel that would host multiple generations of humans, became the focal point of the mission design. The birth of Interstellar Colonization Initiative. Governments tried to cover it all up, but it was too late. In April of 2055, a crowd of 2 million people marched on Geneva, where the G20 Climate Summit was being held. Among them was Amir Hussein, then a student of astrobiology. "We were no longer asking to save this Earth," he recalled years later. "We wanted a second chance." On June 12, 2055, under global pressure, the major powers signed the Tau Ceti Treaty. The Interstellar Colonization Initiative was born with an initial budget of $450 billion, funded by climate bonds, 35%, CO2 emission taxes on corporations at 50%, and private donations, 15%, including a record $20 billion contribution from Elon Musk Jr. But not everyone agreed. The Resistance movement, led by ecofeminist philosopher Aisha Ndoye, argued that the project was an escape for the elite. "Taking away 20,000 people out of 10 billion is a betrayal," she declared at the 2056 People Summit. "Better for all of us to die here in the cradle we've destroyed." But for many, like Javier Martinez, a Mexican agronomist whose village had been wiped out by a Category 7 hurricane, the choice was clear. "My grandfather used to grow corn where there is now the sea," he told the selection committee. "I will plant those seeds on another world. It's the only possible compensation." And that world was officially named Aurora. In this hysterical climate, science became a faith. The temples of the 21st century were cryogenic labs, preserving the DNA of millions of species. The priests were engineers like Marcus Lee, who designed generation ships while tormented by increasingly frequent power blackouts. "We'll build ships made of steel and hope. True arks," he promised in a hologram speech on what was left of the internet. When the first prototype antimatter engine passed tests at Fermilab in Batavia, Illinois in 2057, the crowd that had gathered from Chicago waiting for the big news burst into tears and cheers. They weren't tears of joy, but of relief. For the first time in decades, there was hope of leaving the planet. What the crowd didn't know yet was that only 1 in 500,000 Earth inhabitants would have the honor and relief of boarding the ships. To be honest, winning the national lottery would have been easier. Generation ships, an ark for humanity. Designing the generation ships, named Ark 1 and Ark 2, was a monumental engineering challenge. These vessels had to be completely self-sufficient, capable of supporting human life for at least 2 centuries without resupply. Each ship would host 10,000 individuals, selected through a rigorous process to ensure genetic diversity and the necessary skills to build a new society on exoplanets. The ships were designed as rotating cylinders, creating artificial gravity through centrifugal force. This design minimized the negative effects of prolonged weightlessness. Each cylinder had a diameter of 500 meters or 1,640 feet and a length of 3 kilometers, 1.86 miles, with a total internal surface area of about 4.7 million square meters or 50.6 million square feet. The internal surfaces of the cylinders were lined with living quarters, agricultural areas, water treatment facilities, and recreational spaces. Advanced life support systems recycled air and water, while hydroponic farms provided a continuous supply of fresh food. The hydroponic greenhouses were designed to produce a variety of crops, including vegetables, fruits, and grains, sufficient to sustain a balanced diet for the crew. The propulsion system, known as the antimatter pulsed fusion drive, was a revolutionary technology developed in collaboration with the world's leading physicists and engineers. A microgram of antimatter triggers deuterium-tritium fusion, explains Tanaka. We'll shoot hydrogen particles at 30,000 kilometers per second, about 18,640 miles per second, to produce a thrust capable of propelling massive ships, like the arks, up to 10% of the speed of light, or about 30,000 kilometers per second. It'll take 2 years of constant acceleration to reach that speed, and then another 118 years for the big journey. But there was a problem: cosmic radiation. At that speed, even a speck of interstellar dust can cause enormous damage, said Marcus Lee. To at least partially mitigate this, we've designed a double barrier consisting of a 12 Tesla artificial magnetosphere and a 5-meter thick, 16.4 feet water shield. It might sound strange, but water absorbs gamma rays better than any metal. An abyss to cross. The distance between Earth and Tau Ceti is 12 light years. To illustrate what that meant, Elena Soto, who is now the center of media attention, used a metaphor. If the Milky Way were as big as the Pacific Ocean, making a leap of 12 light years would be like swimming across a 2.3 kilometer or 1.4 mile wide strait. Not impossible, but it requires preparation, courage, and a bit of madness. A madness that wasn't well received by everyone. A significant part of the public expected the ships under construction to head towards Proxima Centauri, only 4.2 light years away. But astronomers were crystal clear in justifying their choice. Proxima Centauri was a very unstable red dwarf, capable of sudden bursts of light and deadly electromagnetic emissions, making it inadvisable to attempt the colonization of its planet, Proxima b. However, some continued to contest the choice based on potential relativistic consequences, fearing that a 120-year journey would result in different time passage on the ships compared to Earth, so that if any of the colonists returned to Earth, they would find themselves hundreds of years into their generation's future. But it was explained that traveling at 10% of the speed of light, the time dilation would be minimal, almost imperceptible. There was another paradox, this time concretely demonstrated: communication. A message sent from Tau Ceti would take 12 years to reach Earth, said Elena Soto, and the response, another 12 years. We can never have a real-time conversation. We will be alone. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. Crew selection. How do we choose who to save and who not? Asked Amara Patel during the first selection committee meeting. The question hung in the air like a shadow. They were seated around a glass table with holograms projecting demographic data and maps of the areas hardest hit by the climate crisis. The problem was simple in its harshness. The two arks could host 20,000 people. Earth had 10 billion. It's not about who deserves it more, said Chen Wei, director of the ICI. It's about who can ensure the survival of the species. The selection process was divided into 3 phases. Genetic assessment to ensure a healthy and diverse gene pool. Technical skills to make sure every necessary role was covered. Psychological resilience to evaluate the ability to adapt to a confined and isolated life. We wanted to avoid a ship full of scientists and engineers, explained Patel. We needed artists, teachers, farmers too. A society, not just a laboratory. The first step was to create a database of 500,000 candidates, representing all ethnicities and regions of the world. We need at least 5,000 variants of HLA or human leukocyte antigens, explained Dr. Rajiv Khan, chief geneticist. This will reduce the risk of hereditary diseases and ensure a healthy population for future generations. The genetic test was mandatory. We couldn't afford to bring recessive diseases, said Khan. But it was a painful process. Many were excluded due to conditions like cystic fibrosis or sickle cell anemia. Crew selection categories. The selection of skills was divided into 4 categories. Scientists and engineers, 45%. Physicists, biologists, doctors, computer scientists. Technicians and farmers, 30%. Mechanics, hydroponicists, electricians. Leaders and administrators, 12%. Coordinators, mediators. Educators and artists, 10%. Teachers, psychologists, musicians, writers. Armed protection, 3%. Military, guards. We couldn't afford to lose knowledge, said Lee. If an engineer died, we had to have a ready replacement. And if a child was born with a talent for music, we needed someone to guide them. The age distribution was also carefully calibrated. 20 to 30 years, 40%, young adults, fertile, adaptable. 30 to 50 years, 40%, experienced with established skills. 50 to 65 years, 20%, elders, bearers of wisdom and historical memory. We didn't want a ship full of 20-somethings, said Patel, but neither did we want a ship full of 50-somethings. We had to balance energy and experience. The final process, an impossible choice. By 2062, the selection committee had narrowed the candidates down to 40,000. We had to choose 20,000, recalled Patel. It was a sleepless night. Every name we crossed off was a life left behind. In the end, the selection was announced in a video broadcast worldwide. It wasn't a contest, said Chen Wei. It was a sacrifice. Those who leave will carry the weight of those who stay behind. Training for a one-way trip. The selected individuals were taken to training centers in Antarctica and the Sahara Desert. We simulated life on board, said Sophia Miller, future captain of Ark 1. We had to get used to artificial gravity, controlled light cycles, and a diet based on hydroponic food. The children were enrolled in special educational programs. They had to learn not only science, but also Earth's history, said Emma Clark, a selected teacher. We wanted them to know where we came from, even if they'd never seen it. Time, a challenge for the human mind. The 120-year journey was not just a technical challenge, but a psychological one. How will we keep morale high for so long, asked Amara Patel, the project psychologist. We'll need to create a culture on board with traditions, festivals, and rituals. We must teach children born in space what it means to be human. Elena Soto added, and we must remind them where we come from, because one day when we arrive at Tau Ceti E, we will have become something different, but we must not forget Earth. The soul of the arks, holograms, and earthly memories. To combat claustrophobia, the arks had holographic domes that projected Earth's skies. Scans of the Amazon rainforest, the Sahara, the Himalayas, explained Amara Patel. At least the children born on board would know what a sunset looked like. In the central section was the DNA archive, quartz crystal discs containing 5,000 years of literature, music, DNA of extinct species, and recordings of human voices. We also included sounds from the old Earth, said Patel. Whale songs, wind in the olive trees, even children's laughter. The last night on Earth. On the eve of departure, the selected individuals were gathered for a ceremony at the orbital shipyard. They told us we were the custodians of the species, recalled Javier Martinez, but I could only think of my mother, whom I would never see again. Amara Patel closed her journal with a reflection. We chose 20,000 people to save 10 billion. Maybe it was selfish, maybe it was necessary, but one thing is certain, we will never be the same again. The birth of the arks. Building the arks in space was the only option. Lifting 2.5 million tons or 2.76 million US tons of materials from Earth would have been impossible, explained Marcus Lee during a meeting. We'll use near-Earth asteroids for 70% of the materials. The rest will come from the moon. The Alpha Orbital Shipyard was established at an altitude of 400 kilometers, or 249 miles, connected to the International Space Station 3, the ISS-3, which had been converted into the headquarters. Astronauts called it the Raven's Nest because of its black and angular structures. It looks like a metal spider weaving its web, wrote Li Wei, an onboard engineer in his journal. The arks were essentially modified O'Neill cylinders, 3,000 meters or 1.86 miles long and 500 meters, 1,640 feet wide, with a habitable surface area of 4.7 million square meters, or 50.6 million square feet, and a mass of 2.5 million tons, 2.76 million US tons each. According to the plan, the structure would rotate at 2 revolutions per minute to simulate 1 g of gravity. We optimized the speed to reduce Coriolis forced nausea, explained Lee. If we exceeded 2 RPM, you would vomit while walking. However, only the central belt was supposed to rotate at 2 RPM, creating comfortable gravity. Toward the outer sections, the cylinder's rotation became too high for a human, and only robots could operate in those areas, where the metal vibrated like a violin string. In practice, concentric sections of the ship were planned with different speeds. The living areas rotated more slowly, while the industrial zones, less sensitive, rotated faster. The shipyard workforce consisted of 5,000 astronauts and 10,000 robots. The robots did 90% of the heavy lifting, explained Li Wei. But for critical connections, we needed human hands. We had to assemble the watertight joints millimeter by millimeter, with our gloves freezing at minus 150 degrees Celsius or minus 238 degrees Fahrenheit. 40% of the steel needed came from the asteroid 2016 HO3, extracted by crab-shaped mining robots. It was rich in iron and nickel, but we had to purify it in space, recounted Sophia Miller, head of the orbital foundry. We used solar furnaces, mirrors that concentrated light into a melting chamber, reaching 3,000 degrees Celsius or 5,432 degrees Fahrenheit. The rest was lunar aluminum, light and strong. The Tycho base on the moon became a bustling city, wrote Li Wei. At night, we saw rockets loaded with metal taking off like fireflies toward the shipyard. But a ship is not just made of metal. The shell is there to protect a closed ecosystem, a real miniature planet. So hydroponic greenhouses covering 30% of the internal surface were set up. We selected 120 plant species, said Javier Martinez, the ship's agronomist. Genetically modified dwarf wheat, fast-growing potatoes, spirulina algae for protein. Every square meter produces 20 kilograms or 44 pounds of food per year. The recycling systems were a masterpiece of engineering. Chlorella algae in bioreactors converted CO2 into oxygen, balanced by emergency electrolyzers. Organic waste was composted in anaerobic digesters to produce methane, used as secondary fuel. The heart of the arks was the antimatter pulsed fusion drive, an 800-meter or 2,625 feet long beast attached to the stern of the arks. It looks like a metal flower, wrote Akira Tanaka in his technical journal. Each pedal is an acceleration nozzle where hydrogen particles are fired at 30,000 kilometers per second, or 18,640 miles per second. The fuel was stored in 20 magnetic crypts, 10 tons, 11 U.S. tons of inverse hydrogen, 10 to the power of 24 antiprotons, produced over 30 years at CERN and Fermilab, plus 500 tons or 551 U.S. tons of deuterium-tritium fusion fuel, sufficient for 150 years of operations. Even if one crypt failed, said Tanaka, the explosion would vaporize the ark in a nanosecond. That's why we have 3 redundancy systems: confinement lasers, magnetic fields, and superfluid helium coolants. The launch. Farewell to the cradle. The day of departure was a moment of global unity and celebration. Captain Sophia Miller, before boarding, left a message in the ISS-3 time capsule. Building these ships taught us one thing: even in darkness, humanity can light flames that last centuries. Now we take that flame to the stars. On June 12, 2065, Ark 1 and Ark 2, shining beacons of hope, left Earth's orbit forever. The slow operation was followed by billions of people around the world, who watched with awe and emotion as humanity took its first steps towards the stars. The blue flame of antimatter lit up the orbit like a second sun. The journey began with a series of engine ignitions that gradually increased the ship's speed to the set limit, a process that took several weeks of constant acceleration to minimize the effects on the crew, and ended just before passing Neptune's orbit. From there, the door to the stars opened. Time and space. Time in space is an illusion. Days passed with occasional jolts of diversity, but years and decades, always the same, blurred together like clouds in a sky without seasons. The arks advanced at 30,000 kilometers per second, devouring the distance between Earth and Tau Ceti. But for those on board, they seemed completely still, and the journey mostly marked only the slow physical transformation of the passengers. In the early years, let's say until at least 2090, Earth was still a vivid memory for everyone. The original crew members, those who had left friends and family, would gather in the holographic domes to watch the shrinking blue dot. "It looks like a pearl," said Marie Subiris, a pediatrician, once holding her son Charles' hand. "A pearl we've lost." But Charles, born in space, didn't understand. For him, Earth was just a story, like the ones Emma Clark told in the classrooms. "What was the sea like, teacher?" he often asked. And she, with a sad smile, would turn on the hologram of a stormy ocean. "It was like this, Charles. Vast like space, but much more unpredictable." The arks traveled 10 million kilometers or 6.2 million miles apart, close enough to communicate via laser and far enough to avoid collisions or shared fates. Each message took 33 seconds to reach its destination. "Ark 1 to Ark 2, all good?" asked Sophia Miller, the captain or whoever was on duty. And 66 seconds later, the response came. "All good, Ark 1, continuing." Meanwhile, the hydroponic greenhouses thrived. Javier Martinez, the agronomist, taught the children how to grow potatoes and strawberries. "This is our food," he said. "It doesn't come from Earth, it comes from our hands." But some, like Lyra Voss, an engineer from G2, the second generation, were not satisfied. "We can go faster," she insisted. "We have enough antimatter." The council refused, but the discontent remained. In 2120, Sophia Miller died. She was 92, and her funeral was a silent ceremony. Her body, wrapped in a flag with the words, "Bearer of Light," was shot into the void. "Goodbye, Captain," whispered Li Wei, her old engineer friend. "Now we're alone." And then in 2129, halfway between the past and the future, came the void syndrome. Hundreds of people, especially from G2, began to lose touch with reality. "There's nothing out there," they murmured, "only void." Doctors tried virtual reality therapy, recreating earthly landscapes, but for many, it wasn't enough. Births and deaths continued. The children of G3, the third generation, didn't understand why their grandparents still looked at star maps. "Earth is far," they said. "This ship is our home." But something was going wrong during those days. It was November 7th, 2132, when Ark 2 stopped responding to messages. The first day of silence was treated as an inconvenience. "Ark 2, you're late for check-in," said Captain Kian Soto, as the communications officer repeated the call. 66 seconds later, no response. 66 seconds of void that first became minutes, then hours. What arrived punctually, however, was an unexpected neutrino wave, the origin of which the onboard computers quickly located at the position occupied by Ark 2 at the time of the last signal. The news spread like a virus. In the central mess hall, a group of Generation 3 technicians, those born with pale faces and eyes adapted to artificial light, gathered around Yu Chen, the first officer. "We have to stop," they shouted. "There might be survivors in the emergency modules." Captain Soto responded with the numbers. "We're at 0.1 C. To stop, reverse thrust, and go back would take at least 2 years. And even then, we'd find debris scattered over millions of kilometers. It would be an impossible search." But the insurgents didn't accept the logic. "They're our brothers. We can't abandon them like we did with Earth." In the following days, they sabotaged the agricultural ducts and blocked access to the engine room. The ship was a frenzied hive. In the command module, Soto consulted the data with Aliyah Voss. "If we divert for a search," Aliyah explained, "we'll consume 7% of the fuel. We might not have enough to stop at Tau Ceti." The next day, Soto called for a general assembly in the central atrium. 2,000 faces, G4 youths with star tattoos, G1 elders with radiation scars stared at him as he spoke. Choose, go back to search for Ark 2 and risk all of our lives, or continue towards home. Out of 6,776 eligible voters, 73% voted to continue. That night, someone wrote on the walls of a corridor, "We betrayed Earth again." That was undoubtedly the darkest period of the entire journey. From then on, tensions and animosities faded, as if that halved community had resigned itself to an apathetic and hopeless existence. From a proud interstellar ship, Ark 1 had suddenly transformed into a lifeboat for castaways. On September 26, 2165, exactly a century after departure, Ark 1 began to decelerate for orbital insertion around Tau Ceti, but they were still far from their destination. Finally, on June 4, 2179, Tau Ceti began to appear in the telescopes as a real disk. A yellow star not unlike the sun. "We're here," Qian Soto whispered. Finally. Driven by a moment of somber reflection, he reread his last logbook entry, a brief census to focus on the human forces still in play aboard the ship. We're 9,887, a number that burns more than cosmic radiation. Generation 1, who left Earth, extinct. Generation 2, born in the first 30 years of the journey, 1,200 members. Dull eyes, bones weakened by artificial gravity. Generations 3 and 4, born in deep space, 7,000. Dilated pupils for dim light, thin skeletons. Children of G5, 1,687. They can't even understand what the Earth videos show or talk about. I watch them all as they go about their activities. Boys with tattoos of false constellations. Women breastfeeding in front of screens showing extinct oceans. We're no longer human. We're a new species. Was it worth it? June 12, 2186, Qian Soto's diary. Remaining distance, 0 light years. We're in orbit around the star, en route to intercept Aurora. It seems impossible. From orbit, it's a mosaic of impossible colors. The oceans are turquoise, streaked with fluorescent currents that shine like veins of light. The continents are covered with pale green forests. The clouds are yellowish, perhaps colored by 2 volcanic eruptions dotting the shadowed part. "It's beautiful," whispered Mira Voss, the G3 astronomer. "But it's not Earth." No, it isn't. And maybe that's a good thing. Where to land? June 14th, 2186. Council recording. We spent 2 days scanning the surface with telescopes and drones. 3 sites emerged as candidates, but almost unanimously the council chose the eastern coast of a continent shaped by vast plains and a strip of land between ocean and mountains, with open waters and signs of geothermal activity. The Shuttle Swarm. June 24th, 2186. Qian Soto's diary. Today's the day. The shuttles are ready. 300 small jewels of metal and glass. Each one carries 30 people, plus the initial equipment. There's a lot of order, a lot of silence. People bored with a grim expression. Many children are crying. The shuttles detached from the Ark like seeds in the wind, descending in line following the trajectory set by the computers. The first ones dove into the atmosphere and immediately disappeared from view. Then, from the Ark's bridge still in orbit, not a single one was seen again. And from that moment, history took hold of them.